Hello again, YouTube. Well, it's been a little while since I've put in one of these videos talking about my computer build here, and I'll explain why. You've already seen this first circuit board many times now. It's probably getting boring. And of course, I've already talked about how this was laid out, breadboarded, and then once it was working on the breadboard, I built the, actually I just told you that backwards. I breadboarded it first from the loose design and schematics. Once it was working, then I planned the layout, and then I built this board. And you know, it came out wonderful, and it's pretty robust. Although I gotta say, soldering it took a little while, and it's not even that densely populated. I mean, there's 2 chips and 2 voltage regulators and a bunch of discrete components, the capacitors and resistors. The hardest part actually was the, I don't know if I'll get this thing to focus, the VGA connector. Yeah, I need to get a better camera. The VGA connector took a long time, and also the SD slot is a surface mount component, and it just took a little delicate soldering, but it's proven to be very robust now that it's done. And so I wanted to do the same thing with the CPU board, and you've already seen in my video I breadboarded it, and it is indeed working. So I planned out a CPU board layout that I thought would be somewhat easy to wire. Of course, look how many more components there are. There's a lot more chips. All the chips at the very least are 20 pins, but the U2 RAM chip is 28, and of course the U1 microcontroller is 40 pins. Plus there's 3 40-pin connectors and 2 6-pin headers, and then, you know, a small smattering of just capacitors, crystal, and a couple of resistors. So I did lay out the perf board, and I started thinking about wiring it, and then I realized it kind of dawned on me, hey, this will take forever to solder up, and that part would not be that fun. That's when I started using some software. You can download CadSoft Eagle. There is a trial version that's free to use, and it's fully functional. They limit you to about 4-inch, slightly smaller than 4-inch square, I believe, circuit boards. There's some different editions. For not too much money, you can upgrade it slightly. The point is that it allows you to draw your schematic diagram and select the individual chips from component libraries, which is upgradable. You link everything together, and of course I linked everything together by referencing the actual computer schematic. So this section in here, this whole square, that is part of the power I/O board, as is this. That's the power jack, as is this. This is the voltage regulator circuit, and these 2 capacitors here. Everything else, these components here, these are 2 40-pin connectors. There's 7 latches here. The expansion 40-pin connector, and then the RAM, 1 more latch, and the microcontroller. All these components are part of the CPU board. So I simply reproduced that in Eagle, which then allows you, and I'm going to click on this here, to lay out your what the actual printed circuit board would look like. I mean, this is a full CAD program. It took me a long time. I mean, you don't start out with it looking like this. You start out with a blank slate of where your PCB will be, and then all of the components are sort of jumbled outside of this. You need to drag each piece to the right orientation and location. And then you get what's called air wires, which are just small yellow lines that are connecting where all your connections are, that the computer gets based on the schematic that you've input. And then next you have to route it, and that's what will actually draw these little traces. The red traces that you see will be on the top of the printed circuit board. The blue traces that you see will be on the bottom. So it's a two-layer board. And then you can there's a silkscreen layer on the top, which is showing which, labeling which chip is which. I actually, by hand, I found a font online that was all in a JPEG and alphabet, and I actually spent a little time and made this nice looking logo for my board on the side. Yeah, it's probably a bit excessive. I put my name on here. This is actually revision 1. I learned several things. For example, that it's smart to have a ground plane, which helps to keep the RF signal, the RF disturbance down, and also it helps to balance. It helps to shield from RF interference, and it also balances the temperatures, and it's just a good solid practice to have a ground plane. So I added that, and it was and probably, I don't know, 8 other enhancements. For example, where you've got raw power coming in, these traces are very thick here. All the power supply traces for the microchips are also a bit thicker than just the generic signal lines. And anyways, came out looking like this, and I sent it away to a board house. Now, the predecessor to this one is this board here. I actually just got this back. I had this prototype board made using the same software, but it was before I was fully refined with my design. I needed to see several things for myself in a prototype. For example, would all the parts that I had included from libraries that I downloaded off the web, would they actually fit the real components? I hadn't yet figured out that I would need to have variable trace sizes to handle the different current capacity. So when you compare just a regular signal wire, it doesn't have to carry as much current as an actual power supply trace on this board. And I needed to see if all the through hole sizes were correct and would allow all the components to be soldered in. I also needed something that I could physically test with a multimeter to make sure that all of the connections from the schematic were indeed in the right place for the physical components, that I hadn't missed anything. So I've been testing this board while I'm waiting for this fully complete board to come in. So anyways, that's what I've been doing. And in fact, once this upgraded board comes in, I will literally start soldering components to it. And you can see it's got the mounting screw holes to that, and the headers here. There's one here, and there's one here. Those have been precisely measured with a micrometer, and they will connect to these header sockets here and here, which will interconnect this board, giving this CPU board its power supply and also the serial connection which is needed to send to this propeller chip, which then completes a VGA or composite video signal and handles the other I/O. So I guess that's a really long way for me to say that once I get this enhanced board in and solder the components into it and connect it to this board here, I'll be ready to wire the front panel to these two connectors on the right side here, and then the whole computer will be implemented and running. And then, of course, I'll be on to the next challenge, which is adding the RAM disk board. I'll probably design another PCB. And I'm half-heartedly thinking about designing a printed circuit board to replace this, because then one of the neat things about this design is I can reuse this board for any computer. It's going to be a power supply and a serial input and output board, regardless of whether I'm using a Atmel 8515 emulating an 8080 Intel chip for this Altair project, or if I'm doing a 6502 for like an Apple II, or 6510 for a Commodore 64, or a Z80 for like a Spectrum or something, so you name it. Anyways, so stay tuned, and next time hopefully I'll have the revision 1 board, that's the one you're looking at now, soldered and running. So I'll talk to you next time. See ya.